Hey, everybody. And today I want to show you one scam, which is designed for such adult hamsters, for hamsters with experience, who know how to use Etherscan and even know a little bit about programming in Solidity. Here we have such an interesting smart contract in the Ethereum network. His hosts put 40 heirs on him. The code of this smart contract is verified, and if we look at it, we can see that this is a game where the host, the admin, are the admins, because here in this smart contract can have multiple admins at this smart contract. They ask the question and the answer. The question is stored publicly. The answer is stored as a Keswick cache, and we have to try to guess that answer by sending a try transaction to the smart contract. And if we guessed it, we will take from that smart contract all the money that is lying here, ostensibly, but we have to pay some amount more than 1 ether for trying. The contract itself seems very simple, only 52 lines, and ingenious hamsters are beginning to think they understand this smart contract. We have a start function that the admin uses to start the question and answer, and in doing so put our winnings, the amount of winnings on this contract. We have a new function that allows the admin to reset the question and answer. We have a stop function that allows the admin to pause the game and withdraw all funds from the contract. And we have a constructor that specifies admins not in the usual way, not as an array of addresses, but the constructor requires some array of variables like bytes 32. Why it asks for this particular type of variables, I'll explain to you a little later when we go to look at the tests I've written for this smart contract. And there's a modifier of admin that to many seems somehow odd and maybe even malfunctioning. Here in particular, one of my subscribers dropped me this smart contract, being sure that this modifier from admin does not work. It actually works fine in conjunction with this constructor, which simply sets admins in a special way suitable for this modifier to work, but we'll talk about that later. So after learning the text of our smart contract, the hamster goes to transactions and the hamster sees the start transaction, opens it, looks at its data. And here in Azure Scan we can decode this transaction and see both our question and our answer in decoded form. So we can see that our response is lunch and dinner to the question of what we don't eat for breakfast. Accordingly, the hamster believes that this is the response it should send to this smart contract and take all the money. But it's not that simple. Accordingly, we do not see a successful transaction new after that and think that the response was not reset after that. But here we also have an internal transactions tab, in which if we enable advanced mode, we can also see in which internal transactions of other smart contracts this smart contract participated. And here we see a transaction that took place on another smart contract. And since our scammer smart contract may have many admins, there may be some contract among them. And in the course of this transaction, which we can decode, we see that the new function from this smart contract has just been called. And the function new, it no longer sets question and answer, question and response in the clear. And she immediately sets it up as his kitty. Of course you can try to pick up this hash brute force, well, that is, going through all possible words, answers, calculating their hash brute force and comparing to this value. But you should keep in mind that even if you manage to pick up the response whose hash matches the one you saw in the internal transaction by decoding it, most likely the scammer is monitoring this smart contract with the help of some bot. And if suddenly there is a transaction with the right answer, he will fight for his 40 ether, with the help of so-called gas warfare, up to the point that all the ether that you send from your transaction, he will put as a reward to the miner. Of course no one will forbid you to try it anyway, but my business, as they say, is to warn you. Similarly, as I mentioned, there is no way to somehow hack the admin of a smart contract, because you don't just throw money around on the internet. It's always just bait in some kind of mousetrap. We can also find quite a few similar smart contracts here in Etherscan by a simple search. They're all a little different. Going through them all, you won't find any such smart contract where someone managed to get this winnings. Let's now go and look at that unit test code that I wrote for this smart contract, because it has a pretty interesting deployment process. In particular, my subscribers had trouble even just getting this smart contract to work because they didn't understand what arguments needed to be passed to the constructor. In the constructor we have to pass a hashed address, a hashed array of the addresses of our admins, those addresses that will manage this smart contract. But we shouldn't put them there in their purest form. We must first make the given address ABINcode, packed and then ISAC 256. Basically, if we look at the ISAdmin modifier, we can see that this is exactly the form we need our admin address to check. Since there are many admins here, they are stored in the admin array at the address of this Keswick hash. And if a given user whose hash of address is in this array and there is a flag true set there, then that person is recognized as an admin. If it is not found, it is accordingly not recognized. Is it possible to find some other Ethereum address that is different from the addresses of our admins, but which will match this KISAC hash with one of the KISAC hashes of the admin's addresses? Theoretically, this possibility, KISAC 256 collisions exist, but practically it has not yet been found at any time at the time of recording the video. So, most likely, if you search for such a free Ethereum address to occupy, you will not be able to pick it up by brute force. In order to get a hash for the address I wanted to set as admin, when I deployed my smart contract into my local development environment, I added a help function to the smart contract here, which purely returned a hash of the given address. You can write that function in the same smart contract as I did, and then erase it when you don't need it anymore. Or you can write some separate smart contract in your local, purely to calculate this hash, to calculate it for a given address. I calculate it for the address, for the account from which I deploy this smart contract to my local network. Accordingly, if this code I just commented out, it calculated this hash for me and I inserted it here. Before I first calculated this hash, in order for my script to work, I simply inserted the right number of zeros here. Now I will comment out this code again and show you how to proceed further and how to work with this smart contract in general. Accordingly, after a given smart contract is depopulated, we can view the address to which it is depopulated. The admin can start the game by setting question and answer. By the way, here's something else I wanted to say. If that modifier from admin suddenly didn't work, we would never see in the transaction history that the start function was successful. Next, I have a test written that shows that we could actually win in the case that after the start function was called, the new function was not yet set afterwards. Again, provided the hosts are not frontrunning at the same address. I also wrote another test that verifies that if we send the wrong answer, our money stays there on the smart contract. And I also showed how an admin can execute the new function and then execute the start function again to reset the question and answer. Actually, all my tests are working out. I caution you against sending one error to the abuser, even if you think you picked the right answer, because he probably won't let you collect your winnings. And put a like if you liked this video. See you all again on my channel. Bye bye.